Okay, so here we have stopped the things. So it says the general solution of the linear equation, quasi-linear equation is the form of ax equal plus by is equal to g is given by this general solution. And then g is an arbitrary functions, as well as the inside pi xy is equal to c1 and chi xy is equal to c2 are solution of the auxiliary equation. We can say this one as pi, this one as a chi, or chi, like that, okay? And this will be the solution of the auxiliary equations, okay? So dx over a is equal to dy over b is equal to g z over g. So what is the a, b, g here? The function before the zx, isn't it? Like p. This is like a ap plus bq is equal to g. So the auxiliary equation begin like dx over this one, the coefficients, okay? This coefficient dy over b, dz over whatever the function this side, okay? So let's see one example for that to understand this concept. For example, let's say if you have the equation, this one, zx 4zy is equal to 6 or something. Can you write the auxiliary equation? Auxiliary equation for this question. From the auxiliary equation only, we're going to solve our things. So can you write the auxiliary equation, which is very simple now? Just to equate the coefficients a, b, g. Sometimes it may be a function or sometimes just coefficients, I mean scalars. So can you send me? Let's see if someone has answered. Okay, good. Okay, at least the registration number 002. If you are available, can you answer me? You said you are here. Can you prove that you are here by answering me?
Yes, ma'am.
Okay, can you try one more?
Yes,
It's very simple, nothing a big deal. Okay, can you try this one? X squared, okay? Y squared zy, which is equal to maybe z squared. Okay, everyone answering, thank you. I need the registration number 002 also. Otherwise, I will take as absent, surely. Okay, can you write this auxiliary equations? So you have to know the coefficient the AB can be a scalar as well as any functions of x, y things, okay? Can you answer the second question? Just the auxiliary equation. We're not yet started to solve it. If you know how to write the auxiliary equation only, we can solve. So can you do that? Okay. So you have to be attentive in the classes, okay? If I am asking your registration number, you should answer me quick as possible. Otherwise, I will take as absent for everyone. Okay? All right. Okay. It's a simple thing, isn't it? So that's fine. Okay. All are correct. So this will be, the first question will be dx over 3, which is equal to dy over 4, which is equal to dz over 6. Similarly, for the second questions, we can have dx over x squared, dy over y squared, which is equal to dz over anything z squared. Okay, simple. Okay, let's have, so we have the theorem. Now let's prove it. Okay, we have some like 15 to 20 minutes. Today's Friday, so I will finish 11:45 kind like that. So I will prove this one. Okay, please write down with me. I will take my whiteboard for that. Okay, so what is the theorem is? Theorem says our quasi-linear first order differential equation in the form of x, a z x, b z y, which is equal to g. Okay, this is our first question. Our general solution will be g pi comma chi of is equal to 0, where pi will be a function of x, y is equal to c1, and chi will be a function of xy, which is we are taking as a constant to c2. Okay, where c1 and c2 are arbitrary constants, and our auxiliary equation will be, if it's so, our solution in the auxiliary equation, which is dx over a, which is equal to dy over b, which is equal to dz over g. So what's the thing is proving is, we are proved to have this auxiliary equation, I guess. We need to get this auxiliary equation by proving this one. Okay, that is the proof of this. Okay, I'll try to prove it. Okay, so write with me. So a proofs begin with like this. Right now, suppose let's have our pi is equal to c1 and chi is equal to c2, and okay, and pi is equal to c2 are solutions of our auxiliary equation dx over a, which is equal to dy over b, which is equal to dz over g. So we are taking it as our solution. This pi and chi is the solution of this auxiliary equation. Okay, this is our equation number 1. Then we must show that g of pi comma chi is a solution of our first order quasi-linear equation a z x plus b z y, which is equal to g. Okay, let's take this as a second equation. So we have two equation from the auxiliary equation. Then we are taking one arbitrary functions g of pi and chi, which is the solution of the entire linear quasi-linear equation. Okay, so we're gonna begin from here. So then differentiating this g pi comma chi is equal to 0 with respect to x. I need to erase this window, so please write with me quickly. Okay, differentiating this arbitrary function with respect to x, we will have, so it has two variable now, pi and chi. So I need to have a, daba g over daba x can be written as using the chain rule. I hope you remember the chain rules. Okay, daba g over, first of all, I need to find daba pi. Then that daba pi will be only depend on x. Okay, so I can write this one pi x comma y. So you have to know, in the theorem I have given, pi is a function of x and y. So if you wanted to differentiate with respect to x, first of all you have to differentiate this g by pi, then that pi of x. This is a chain rule, isn't it? Similarly, daba g over daba, there are two, no, pi and chi. First we have found the pi one, and for this chi, again chi also depend on x, no? So you can write like this way, which is equal to 0 as well. Am I right? Because G is a, this side RHS is a 0 now. Okay. Shall I continue? I need to erase this window. So see here, these two are this phi, not only x, it is also depend on y, z. They take us, let's say z also. Okay. X, Y, Z also. So it has three variable, independent variables are 3. So it has to be taken another way. Okay. So it's not a simple one. You have to go through again to take that one. Okay. So let's include that one. So shall I erase this window? Have you all copied? Or otherwise take a screenshot or anything. Okay. It will be easy for you. Okay. But I'll erase. Okay. Okay, I'll go through again, write down continuously. But we know dabba pi over dabba x is not only depend on x, we have 3 variables. So I can write this one as dabba pi over dabba x of x. I'm just writing for your clarification, okay? This is dabba pi over dabba y also there, where dabba y should have to differentiate by x. And again, this is also depend on dabba z. So dabba z also dabba x. Okay. So what do you think? This one will be 1, no? Am I right? What do you think? This one? Y is not depend on x, no? So this will be 0. So this is our zx. Am I right? Yeah, so we can simplify this equation as dabba pi over dabba x times 1. So I'm not writing this one. This term is 0. Only this term there. So I can write zx dabba pi over dabba z. I'm taking dabba z front, okay? So let's take this one as our equation number 3. Also, similarly, you can write for dabba chi also, okay? Dabba chi over dabba x also. Similar way, you just write down, okay? So I'll write the second step. This will be dabba chi over dabba x, which is equal to, yes, zx, dabba chi over dabba z, I guess. Okay. Let's take this as a number 4. Same thing happening here, right? The only thing you have to substitute chi. So why we are doing, we're going to substitute in our equation number 2. Okay. So that is a bigger one. Now we are not writing inside the bracket. We are writing separately. Then we're going to substitute there. Okay. Okay. I'll continue because we are run out of time. Okay. Now substitute in equation number 2. We get dabba g over dabba x there. For the dabba g over dabba pi times, for the dabba pi over dabba x, you have to substitute dabba pi over dabba x plus zx times dabba pi over dabba z. Okay. Plus dabba g, okay, dabba g over dabba chi. For the dabba chi over dabba x, you had to multiply this one, dabba chi over dabba x plus zx times dabba chi over dabba z. Just equal, okay, that's all. Okay, just equal to maybe 0. So we also know our g depend on phi and chi. So chi and pi depend on x, y, z. Maybe chi depend on x, y, z. Okay, so that's why we are doing this one. Using the chain rules and all. Okay, similarly, Continue like that. Similarly, what do you think? Daba chai over daba y? So you don't need to derive again, no? Only thing is you have to substitute in this equation. Better you substitute only y, wherever y, okay? And it will give you, if you want, you can derive, okay? I'm gonna skip that part. So daba g over daba pi times, yeah, daba pi over daba y plus daba g over daba chai times daba chai over daba y, okay? So if you substitute this like for this one, you will have something daba g over daba pi of daba pi over daba y plus zy, no? For this one, zx, there zy. Okay, daba pi over daba z, same. Okay, plus, can you write down daba g over daba chai of daba chai over daba y plus zy times daba chai over daba z. Okay, so please, I could write here, just write down nicely. All are same thing, so here daba pi over daba y, daba z, sorry. Z is equal to 0. Okay, so you can give a, okay, let me wait. Okay, what is our numbers? 1, 2, 3, 4, maybe 5. This is 6 or anything. Okay. Okay, I'll erase this one. If you are not finish up, please leave a spaces. Okay, so you can take a screenshot and you can fill up later. Okay. Yeah, it's continue like this. Okay. What I'm gonna do is see where from this, see whether it is correct or not. Okay. Daba g over daba pi, it is the, if you simplify the things, you will get like this, which is equal to, you may have this way, daba chai over daba x plus zx daba chai over daba z. So from those two equations, you can get this one. You try it, okay? Daba pi over daba x plus zx daba pi over, sorry, daba pi over daba z, okay? Which is also equal to daba chai over daba y plus zy times daba chai over daba y daba z divided by minus daba pi over daba y plus zy daba pi over daba z. See whether from those two equations, if you divided and taken that side and this side, you will have this one. Okay, see whether it is correct or not. So leave a space, just write the this last part, then you can check later. Okay, you don't have time now, so you can check whether it is correct. Hopefully it is correct. Okay, please write nicely correctly. Okay, you are dividing daba g over daba pi and daba g over daba chai, but you are getting the chai in the numerator and pi in the denominator. Similar wise for the y also. Okay, so it will turn around like in that way. Okay, now, so we have this one now. So I'm just, you have this one. Let's say I got this one now. Daba chai over daba x plus zx daba chai over daba z divided by this is equal to this divided by this, no? So if you cross product and take out the negative signs, you will have something this one. Okay. Okay. Our meeting again gonna finish 10 minutes. So that is our last. Okay. So no need to join again. Okay. Here you will have da bar chai over. I'm just cross producting. Okay. Da bar x plus zx da bar chai over da bar z times this part. Okay. What is this part? Da bar pi over da bar y plus zy da bar pi over da bar z. Okay, which is equal to, you can write these two terms. Okay, cross product this and this. And then I'm gonna keep the things for yourselves. Okay, you have to fill up. If you take all the zx terms, okay, you will have something minus something. Okay, and if you take the zy outside, you will have this one minus again another terms minus, which is equal to, you will have this minus this. You find out, you fill up these brackets. Okay. Okay. It's a simple thing. Doesn't see this one also zx there. So you have to multiply this and this. Similarly, here also some zx there. So you have to multiply this and this. So you have to take this side and that side. So it will be minus comes. Okay. So zx, if you take bracket of zx and zy, you will have like this form. Okay. And the remaining this and that terms will go this side. Okay. Hope you understand. So put the number 1, 2, 3, 4, 5, 6. What is that? 7 or something? I don't know. You just put the continuous number. Okay. Okay. I'll erase it and yeah. So then write continuously, since we have pi is equal to C1 and we are taking this one now, chi is equal to C2. Are solutions of the auxiliary equations. Then we are finding, okay, we seek a relation among, that is, I mean, pi x, y, z is equal to C1 and chi x, y, z is equal to C2. Okay, these two are the solution of the auxiliary equation. So we are finding the relations. Okay, that is d pi. You already seen this one. Da bar pi over da bar x dx plus da bar pi over da bar y dy. We have three elements now, so you have to write da bar y over da bar z of dz. Okay. Similarly, if you find for d chi, that is also d pi over dx plus da bar pi over da bar y dy plus da bar pi over da bar z dz. Okay. Please write down this one. So it has dx, dy, dz. Okay. Okay, I'll erase this one. Now, write down. Therefore, what is our dx will be da bar pi over da bar y. Okay. Let's start again. Okay. So from that we can conclude dx equal to the modulus of, okay, da bar pi over da bar x y, da bar pi over da bar z, and da bar chi over da bar y, da bar chi over da bar z, which is equal to dy over da bar chi over da bar x, da bar chi over da bar z, similar one, okay, da bar chi over da bar x, da bar chi over da bar z, which is equal to dz okay. There's a modulus. From the equation 8, you can derive this one. Okay, so continuous. Since this is similar to the auxiliary equation, so g pi comma chi is equal to 0 satisfies the equation a zx plus b zy is equal to g. Okay. Okay. From the equation 7, see there something zx, something zy, which is equal to something we got no. Here there's a minus, something like that. Okay. So this equation is they are taking this way. So we have the auxiliary equation is what? Dx over a is equal to dy over b is equal to dz over whatever g no. So what is our a? We have, if you see that, you will get this one. What is the modulus? 2 cross 2 modulus. Let's say this is A, B, C, D. What is the modulus of this 2 cross 2 matrix? AD minus BC, no? So if you see that A will be da bar pi over da bar y, da bar pi over da bar z minus da bar pi over da bar z, da bar chi over da bar y. So it will come like that. So if you done correctly all the equations, you will see this is our A. Okay. A, they have written, this is in this form, they have written in the modulus form. Okay. Similarly, B also, C also. Okay. So whatever come, this one is the A part, this one B part, this one is a G. Okay. So if you see that one, it is kind of this format. If you see that, it will be in this form. Okay. So write down at last. Okay. So therefore, G pi comma chi, our session gonna finish, so I'll write quickly, okay, is a solution of a zx plus b zy is equal to g. Okay, that's all the proof, hence proved. Okay, so hope you get the idea. Just go through again, write all the steps and see whether you get the idea of proof. Okay, so we can continue from next class. We can solve some kind of questions using this auxiliary and this solution method. Okay, so if the session end, you can that's all our course today. Okay.